So I showed machining some of these adapter plates in a previous video. I mentioned that I may machine a couple more, and that's exactly what I'm doing. I just had Joe burn me out 2 more of these 1-inch thick steel plates since I had everything set up, and I wanted to just continue making a couple more of them so I can get a little more practice on adjusting my program. So this first one here looks a little bit different from the last ones that we machined. I decided to swap back over to finishing the milling using the 2-inch tongue-alloy face mill instead of the 1-inch tongue-alloy face mill. And I've also been changing up the depths of our chamfers there, trying to make those look better, more uniform. Same thing on the outside there. I decided to put a larger chamfer on the outside there as well. I've been tweaking my program, making slight changes. I've even made changes that's going to be applied to the next plate here with our feeds and speeds for the mill. I'm hoping to maybe improve the finish here a little bit. The finish looks good, but if you're looking for that really pretty, shiny milled finish, I got to do some improvements on that. But the finish is good, and everything is on size right there. With the exception, you might notice this little step right in here. So I made a mistake when I first started this. Put it in there, and I thought that I centered it up correctly, but apparently in Y I made some kind of mistake whenever I had probed it in Y. It was actually offset about that amount right there. So once I realized that it wasn't milling in the right spot, stopped it, reprobed it, and it continued on. But this little bit of key area that's missing is not going to hurt the thing at all whatsoever. So I'm going to put the other piece of plate in there and go ahead and machine it as well. I may use my phone and get a couple of short videos to share with you, maybe doing some of the chamfers, just because of you've already seen it being milled once, and I don't want to take you through that whole process again. But just trying to improve my programming here with our conversational over onto the Milltronics here, okay? So I'm going to go ahead and get started on that second adapter plate now. All right, we're making our finish pass there with our 2-inch tongue-alloy face mill there. This is the op where I was trying to improve the finish just a little bit, changing up the feed rate. So we're running the max surface speed on that particular insert, 660, and then I slowed the chip load down to 5 thousandths per tooth with the hopes that maybe we'll get a little better finish on that, but we'll see. Just about through with that, and then it'll come in with the 1/4-inch end mill to finish out that key. Going around the tool 3. I thought I had an optional stop on that, but I didn't, so I'm just going to go ahead and just stop spindle there. I just wanted to look at the finish before it goes any further. Doesn't necessarily look any better, but it'll work. It's nice and smooth. It's just you see the tool marks there. So anyway, we're going to keep running. All right, well, I just finished up the second one, op 1 anyway, and where I was thinking I was going to be improving the finish, I don't think I improved it at all. Seems like it actually is a little bit worse than the first one there. Not that it's a bad finish, but I was really trying to get a little more polished look out of it, but that's going to work fine. This is just some more stuff that I'm trying to practice on and and get a little better. But I did have some inconsistencies with the first two by a couple thousandths there, so I was trying to improve this one. So anyway, it's gonna work just fine though. So now we can take it out and reset the machine for operation 2 and finish out the other side. So this is the second adapter plate for the second batch. So this is plate number 2, and I made a change. What I did is I went ahead and I installed my Walter 2-inch face mill. I wanted to see if I could get any better performance or finish compared to, let me see, this is the one that I've been running right here. This is my Tungaloy right there. It's got the square inserts, and I wanted to just go ahead and try the Walter shoulder mill. And this is where I've got to keep playing with this and experimenting on recipes on what's going to give the best finish. Now I'm running a fast feed rate on this, but I haven't figured out that sweet spot of surface speed and feed rate to get that really nice finish that you want on a piece of steel plate. This just being a practice piece, it's not a big deal, but that's why I'm doing these, is because I'm trying to get a little bit of experience on something that doesn't really matter. This isn't something that I'm making for somebody that's going to send out and they're going to go, wow, that's kind of a ugly looking finish there. I think it's fine. I want to try to improve that finish. So I'm going to go ahead and start on op 2, and I think I'm going to adjust our feed rates on this whenever we go to mill the bottom side of that, and see about maybe slowing the feed rate down when we go to make our finish pass, and see if that helps or not. Now we're going to probe the bore, find the center of the hole there. Get it kind of centered, about like that. So we've got our plate flipped over there. We've already centered up on our centering hole there. We've got that probed in the middle. So I've been modifying my program to change. This is where we used our 1-inch tongue force rec. I'm going to go ahead and try it with our 2-inch Walter face mill right there. So I have already gone in here and made the changes that I need to the tool, the cut width, and things like that. So if we hit our preview there, that's milling the outside frame with our 3/4 end mill. And then this is where our 2-inch Walter mill should come in there. Let me slow that down. And you can see it's going to generate the same kind of tool path, but I just want to kind of compare the difference between what we are getting with our 1-inch face mill or end mill to our 2-inch face mill there. So it'll make 2 cuts, 55 thousandths stepped each, and then it comes back in, and this is a finished cut there at -125, 25 thousandths for a cleanup cut. And I slowed the feed rate down by half for this right there. And I'm going to see how it does, and just kind of compare it. So hopefully I got things right, and I'm going to go ahead and get started on this plate here. All right, starting with our frame, using our 3/4 inch end mill there. Changing our speeds. That RPM seems to sound better. Now to just go around again for a finish, that spring pass. All right, I know you guys can't see it, but this is our Walter 2-inch face mill. I've got it set up based off of some specs that I got right off of the Walter app there for this mill. So we're running 692 feet per minute and an 8 thousandths feet per tooth right now. So that's 63 inches a minute. So what I did is I dropped it down to, I can't remember, either 30 or 35 inch a minute for the finish pass, and I want to see what it looks like there. Trying to keep it flooded with coolant, but you can get a better idea of the tool path there. I've also got it set at 2 roughing passes because I didn't know if it would handle 110 thousandths in one pass. I think it will, but I wanted to just go ahead and take it in 2. So when it's done with these roughing passes, we'll take a look at the finish and see what it looks like there. The other thing I was going to point out, I forgot to mention, the torque on the vise there, I may have been over tightening it on the first 2 plates, so I tried not to over tighten that. I didn't use a torque wrench, I just used a handle there, but going by feel, I tried to get it to where it felt like it was tight enough, but it wasn't squeezing it and bowing the plate. All right, we're on the finish pass now, and I realized on the previous cuts there where we were doing our first 2 roughing passes, I never did change the cut width. It was still set at 3/4 of an inch, so that's why it looked like it wasn't taking the cut width that I wanted it to, and I realized that I forgot to modify that in the program though, so something else for me to learn. But the other problem that I was having is once it came over to the finish cut, I did have the cut width changed on the program to 1 3/4. I just forgot to do it on the previous op there. But what it was doing, it was going past the machine limit on X, and it wouldn't run the program. So to get by that, I changed the cut width for this finish. I tried it at 1.5 inches, it still wouldn't do it, so I dropped it down to 1 inch, and that allowed it to start cutting, and it wasn't going past the limit. I don't know why it needs to go past the plate so much in order to start the cut, but that's what it was trying to do. So anyway, we're making headway now. Whatever I'm through with that cut, we'll blow it off, and I'll show you what the finish looks like there. So I dropped it down to 30 inches a minute for our finish pass to see if it does anything on the finish here. A little bit of experimenting and learning here as we cut these next 2 plates. So there's our finish. Certainly not as pretty as we did with our 1 inch there, but it looks like it did a good job. It's got a good feel to it. It's even. There's no steps in it. So that was running 30 inches a minute with the Walter at 1300, let's see, 1321 RPM. So that's supposed to be 692 feet per minute on our speed and 30 inches a minute on our feed there. So we're just gonna let it go, and then we'll continue on with our finishing out. We just got to cut the keyways there to size and then do all the chamfers. I come back in for a spring pass. That's all it's doing. All right, there we go. Should be doing our chamfering now. Turn that off. Forgot I had the coolant on. Well, I'm showing the two plates side by side here, even though it's not the correct side. But this was our Tungaloy face mill. This was our Walter face mill right here. I think the pattern, or the finish, should I say, actually they look pretty similar. This one just got a lot wider tool path there, but for some reason, where this is positioned at on the machine, the tool wants to come over here, and it's trying to travel beyond the limit. So the only reason I could the only way I could get it to work was to change our cut width down to 1 inch to get it to start over here and then come in to do that. I guess otherwise the vise needs to be this way a little bit further, and I didn't want to have to reposition it for that. So anyway, I'm just kind of showing you the difference between our two face mills. I think both of them are acceptable. I think both of them are doing about equal on our finish there. All right, so this one is now done, and I'm going to put this one in there, flip it over, and go ahead and get it finished out too. So there's our second set of adapter plates finished up. I wanted to put them side by side so you can kind of see the difference in the finish. This one was the Tungaloy face mill. This one was the Walter face mill. Getting some differences between the two finishes. Both of them are fine. There's nothing wrong with that, but definitely room for improvement there on the two. The Walter is leaving more of a rough pattern through there, making me feel like maybe one of the inserts is lower than all the other ones, making that pattern on there. So I'm not sure. I need to get it in the Heimer and actually measure it and see if I can tell there. So this one is a little bit more uniform on the finish there, but like I said, both of them are working fine. So I've gone around there with the mic and measured it all the way around, and we are getting some inconsistency. So these are not perfectly flat. In fact, I don't even want to show, sweeping across there, because I'm telling you that they're not flat. I'm getting inconsistencies in the thicknesses all the way around 0.003 on both of them there. Okay, it's a little bit thinner in the middle. If you might hear in here, it's a little bit thinner than it is out here on the edges there. Okay, so as I said before, when I machined the other ones, when we use these and we bolt them in, we got the V blocks on there. From that point, once they're bolted down and your workpiece is pulled down to the V block, we'll have to sweep the top of the part with an indicator and then just put some shim stock in there in the V block between that and the workpiece to get the workpiece level and parallel to the bed there. But anyway, this project is finally finished up. I had a lot of fun working on it, and doing these projects are helping me remember more each time that I go in there and make some adjustments to the program. And I've even got 2 more right there. So this is going to be another project that I hope to start very soon. We got 2 more 1-inch steel blocks for those 2 V blocks right there. I want to get them cleaned up though, get the rust off of them. They've been sitting around for about, 8 years or so. And they got some rust. I want to get them cleaned up. Need to mill a key on those, just like we did on the cast iron V blocks. And then do basically the same thing on these that we did with these. But I'm going to try to have, once we get to these plates here, I want to have these supported a little bit better, since these are actually longer than the other ones. So what I was thinking about maybe trying is 2 vises, or maybe even our Saunders Machine Works mod vises have one, on each end supporting both ends there. But we'll see. That's probably the way that I'm going to go. But anyway, I'll share this project once we get to that too. There's a little better look at the V blocks right there. I'm going to drop them in the evapor rust and get all the surface rust off of them, and then stone them real good. We might set these up in the manual mill and just go ahead and mill our keyway manually with that. But these are going to be another CNC project. So I just got my other 2 Tico work holding machine vices in the other day. Got them unboxed and up here on the machine, and they are ready to go. I've had these on order for a few months now. They've had a backlog on these guys. But now we actually have 4 Tico vices. We still have the other one is right here, still mounted up where we had it, where we used it last. And so now we've got 4 vices we can use on the flex bed here. It's going to be very helpful for long work pieces. If you got a long piece you want to hold to do some machining, drilling, whatever, we'll have 4 of these vices all trammed in there together. So that's why I got 4 was that so we'd have some nice work hold in here when we need it for the long work pieces. All right, and I decided that I wanted to go ahead and invest some of the Mighty Bite Talon grip, the Vise jaws and the Talon grips. Whenever I was at IMTS last year, I got to visit with the Mighty Bite and see all of their different work holding capabilities. And the Talon grips was a big interest to me. So I bought 2 pairs of Vise jaws so that we could use them on any of these. You can use them on any 6-inch milling vise that you want to. But I got 2 pairs of Vise jaws and then the Talon grip inserts that's going to go on top. And that got me to thinking about this other project that I was on recently, where we machined these fixture plates here for the big V blocks. If you go around both of these fixtures and mic it, you're getting about 0.003 difference in thickness, okay? It's not gonna kill the job. It's not gonna ruin what we did here. What we may have to do when I go to use these V blocks is I'll have to do some indicating across the top of the workpiece and possibly do some shimming in here to get the workpiece parallel to the bed. So I've done that plenty of times in the past when I use these on the board mill, so it's not a big deal. It got me to thinking whenever I was machining them over here on the Miltronics, I was using these really nice Piranha jaws from USA, and I've never actually measured or inspected these because when I was measuring the plate thickness of our fixture, of course they weren't perfectly parallel, the same size. And I didn't know if there was a possibility if maybe these guys are off a little bit, you know, even 1/1000ths on height, being a matched height. And that's really important if you're going to take a workpiece that you don't plan on grinding, you know, it's just a machine finish. You do your machine work and it's setting on this parallel edge here. You go to flip it over and machine the bottom side. You want it to be the same thickness all the way around, so it needs to be parallel. So it got me to thinking that I'd like to go ahead and measure these, and the new ones that I got from Mighty Bite, I want to do some inspection on them and see if they're all the same height, so that when they're bolted in, this ledge here is the same height from the bottom. The Vise jaw should sit on the bed there when you tighten it up, and this should all be the same height. So that's what I want to do. I'm going to take these guys there, wipe them off, and I've got our new Talon grip jaws from Mighty Bite, and let's go in there to the granite plate and do some measuring and inspection work on these and see, let's eliminate these from being a possibility of them not being parallel with each other, okay? So we got you in the office now, sitting on our beautiful Starrett granite surface plate, and this is where we're going to set up and inspect all the jaws here. So these are our new jaws from Mighty Bite. These are the Talon grip Vise jaws. And the way these come is they come with some of these Talon grip inserts there, but these are some of the additional inserts that I bought made for these wider jaws right there. These are the more heavy duty version that I wanted to get right there. And I believe they're made to fit either a 6-inch or 8-inch vise there. So you can get these in different widths, and they just simply set down in that groove, and it comes with the screws you need, and you can bolt these in. You can get wider ones, and you can fill the whole thing up if you want to. So these are made similar in design as our Piranha jaws here from okay? Same concept, where you have this serrated knife edge there with an edge, a parallel for you to set your work pieces on. And when you tighten it up, this kind of helps bite into the workpiece and helps prevent it from lifting up out of there. All right, so that's what I want to do, is measure all these and see, because these should all be the same height. Same thing with our jaws there as well. So I just wanted to point that out. This is the paper that came with it, so anybody that might be interested in these, it's the Talon grip. I also have the Versa grip as well. Those are going to be great. I saw these at IMTS and I thought they would be very handy, because you can use the Versa grip for holding rounds, odd shaped pieces, larger diameters, things like that, because of the way those are made and they swivel around. It's still going to be a little wait before I get these guys coming in before they arrive. All right, so I wanted to point out that I got all these cleaned, by the way. Now you can certainly take a micrometer and do some measuring, and that will tell you whether these guys are going to be parallel or not, and if you have any inconsistencies. So I'm actually measuring these guys. I think they must have a standard size of 2 7/16 because that's what I'm measuring. And I'm measuring with the mic within a few tenths of each other, okay? But with the granite plate, it's nice that you can set an indicator up. We'll move you over there so you can see that. And you can basically just take and sweep the parts with the indicator very quickly to see any kind of differences that you might be getting. But if you don't have this kind of set up, like I said, you can take a micrometer and just go around and measure all the sides and compare the readings to see if they're square and parallel. All right, so let's move over here and use our test indicator and do some sweeping of these and see what kind of inconsistencies we might have in them. So the first thing that I did is I took a gauge block stack up, since I was micing 2 7/16. Now this is a gauge block stack up of exactly 2.4375. And this is what I use to set our dial indicator there to a 0. You don't have to do this, but this is another good example of using gauge blocks to set a standard height off of the surface that you inspect against. Okay, it gives you like a known reference 0 there. So we want to make sure that our granite plate is nice and clean. This is a constant battle. When you're in an environment like I'm in, every time you walk, you're just kicking up dust, and dust is settling all the time. As soon as you move, more dust is settling. So anyway, we took our gauge block stack up there. You guys, I think you can see this. And we went ahead and tried to set us a 0, and it's staying pretty consistent right there where I've got it. It kind of moves a little bit with this fine adjust. You can walk away and come back and it's moved 50 millionths there, but you're just kind of referencing a 0 is all that matters. It doesn't really matter on what number that you're on, but we want to try to use 0 as our reference. So we've got our height there set to exactly 2 7/16 with our gauge blocks. All right. So now we can go ahead and let's just bring them in as pairs, shall we? Go ahead and take these guys and just kind of wipe them off again. And make sure there's no dust there when we set them down. Now, when we're using these jaws, when these guys are bolted in, the thicker part of the jaw is actually what it's pushing against. So whenever you put these in there and you got a workpiece in there, you're using this thin edge here to set your workpiece down on. Put these in there so you can kind of see. I'm sure you guys follow that, but so we're not really worried about what this side is measuring, although it's important that it's all in the same plane there. There may be some cases where you're using this side there as well on the back side of the jaw, okay? But we're mostly going to be using the other side, the thin rail. So I'm going to just kind of put them close together here, and I want to make sure that you guys can see it, and I may come in there with my other camera and try to get you guys a tight shot once we kind of show you the overall of what's going on here. All right, we'll take our indicator base, make sure there's no dust or grit underneath it, and come in, and now we can kind of take our comparable reading and see what it's doing. Now right off the bat, you can see that it's not a completely flat surface there. It's kind of tapering off a little bit as it comes into that inside, all right? Let's come in here to our parallel edge that we're going to be using mostly and see what it's doing. So it's around 1/2 thousandths on the plus side of the indicator. Let's come over here to our second jaw. It's around the same thing as well, about 1/2 thousandth. So they're pretty close to each other, but they're not completely parallel to each surface there. And if you come over here to the edge, right on the edge of it, it actually goes up about another 1/2 thousandths and then drops off. I don't know what the deal with that is. It could be the cutter that was used whenever these were manufactured, but I found that that's pretty consistent anywhere you measure on these jaws, if we come down here to the right side, we come in, it goes in about a half, but there is a few tenths difference. So what I'm seeing is that the jaws are slightly taller in the middle and drops off on the end by about 2 or 3 tenths or so. But right on that edge, right on the inside edge, it kind of lifts up a little bit, not showing as much there. Let's come over here to this jaw. So right there in the middle, you're about 4 to 5 tenths plus, and then when you go back to that edge, it goes up to almost 1/1000th there. So right along that edge there, and I know that it's there because before we set these guys down here, I used my precision flat stones and went ahead and stoned them to make sure there was no burrs. And there was actually a couple burrs on 3 of them, just probably just from handling, you know, putting them in the box. You can kind of see right in there. You see that the brighter area. So I did have to stone them a little bit so that they would sit flat. And when I stone this side as well, you can see there's a bright area there where the stone is touching. And then, I don't know if you guys can see it or not, I'm trying to get a reflection there, but just on that edge, it kind of polished off the black anodized. So it's got just about a 1/1000th raised edge right there, right on the very edge of the jaw. And that's consistent with all of them. So what it's telling me is that the jaws are probably machined within specs, you know, within Mighty Bite specs, and this is not going to give you, this shouldn't give you any problems with your own manufacturing. I think if you wanted these guys better than they are, you're going to have to take them to a surface grinder and actually grind them at that point. Just depends on what your tolerances are for your machining. You know, most things are a machinable tolerance. You have a tolerance to fall in there, and if you're within 1/1000th or 2, depending on what it is, it's probably okay. Now, some things are going to be, obviously, you're going to have a tighter tolerance than that. I wanted to come down to this side and check this one too again and see. It's a little bit low compared to the middle. The middle is about a 1/1000th there on the indicator, okay? All right. We'll come over here to this side as well. I think I can reach in there and get this back side. You see how the indicator kind of moves there? So it's low on that inside edge, and as it comes out here to this side, it actually goes up. All right, about 1/1000th or so. So I think that's, I don't know, it could be their setup, it could be a bad cutter, I'm not really sure. But let's go ahead and let's move these guys out of the way. Hinging on the ends there. Again, these are not ground in any way. These are just machined and anodized. All right, let's see how these measure. That's about the same on that edge. Let's see if our parallel edge is, okay, 1/1000th on the indicator. So right at the same height as those guys there. Let's come over to our second one. Now that one's a little bit, there we go. That's that edge that I was coming up on. See how it's on 1/1000th on the dial there? That's the very, very tip edge of the jaw that's doing that. And you come back a little bit with the tip and you're about a 1/1000th. So I would call these guys, they're all very close to each other. And that's answering my question as to whether or not they weren't the same height. You know, if you were talking about a, you know, couple thousandths difference there, then I would be more concerned about this. Let's come down here and check the end and see what it's doing there. A little bit lower on that side. That one's about a 1/10 there. Low right there on, see how much lower that one is? But you see how sweeping it with an indicator on a granite plate kind of tells you to tell. You can see that the part is not, this surface is not 100% parallel to the bottom where it's sitting. And it's a lot easier to see that with this kind of setup here versus trying to measure it with a micrometer. A little bit low. Like I said, it was a little bit higher in the center and it kind of drops off a couple of tenths each side there. Yeah, so they're all pretty consistent. They're all kind of like, they all seem to be machined the same, within a few tenths of each other anyway. So anyway, that was a little setup that I wanted to see on these brand new jaws before we even bolt them up, just to kind of see if they're all the same height. And once we bolt these into the vise and set our workpiece down, is it going to be parallel on these jaws and when you flip it over? And that's answering my question that it is, but it depends on what your definition of the tolerance is going to be, right? So let's go ahead and check our MMM USA Piranha jaws and see if they're within spec, because I've never measured those before. All right, I've cleaned these off real good. I've stoned to make sure there's no burrs on them. I want to make sure that the dust is off of the granite here. And see how it's hinging. When you hinge it there, it's hinging directly in the middle. So that's telling me that it's not completely flat. Go ahead and get this other one ready too. All right, and I think we're going to have to reset our height on our base right here. So let's see. Let's see if I've got some fine adjust. Yeah, we still got room to fine adjust. This is my indicator base that was made for me by Steve Barton over at Solid Rock Machine. Did a beautiful job on this. Custom make these to order. He put my name there on that side, A-Bomb 79. This is adjustable. You can move this guy around where you want to and just install one of these Noga articulating arms on there to hold your indicators. This is where it gets really touchy. All right, I think we got a pretty good zero there. So what I'm going to do is just actually move these guys down a little bit. I'm just going to use the base and just kind of slide it where I want it. Pretty close. That's within about a tenth there on that side. And you're about a tenth on that one there. So there is a few tenths difference there. That's about 2/10 low there compared to the middle. We should have a, sorry about that, I didn't mean to run it up on there that fast. We got a 0 there. And then this side, where was it at? You got about a 1/10 there. So approximately 3/10 difference from one end to the other, okay? That's pretty good. I never checked that before. So I'm gonna go ahead and move this one over. And I'm just measuring this side for now because this is, when the vise jaws are bolted into the vise, this is the side that I'm mainly using. I'll flip them around and check the other side there as well. All right, so that one, so they're not matched. They're definitely not matched. So it looks like we're about 7/10 lower on this one right here. About 7/10 compared to this one over here. Let's come down to this side and see what it's doing. That's 4/10 low there. So you can see where that, remember, let's see if, was it this one? Yeah, it's hinging in the middle, so it's kind of drops down in the middle a few tenths. So it'll probably be a little bit higher on this side than it is in the middle. And not necessarily. That's about 8/10 low on that side there. So part of the problem is this jaw is slightly lower than this edge over here on this side. So that's what's going on. About a 1/2 thousandths, if you just kind of averaged it out, you're about a 1/2 thousandths or so lower on one jaw than the other. And that side's a little bit lower right there. Let me bring this one back in there and check that again, just make sure that I'm remembering that's the right readings. Yep. So you're definitely getting about a 1/2 thousandths difference in height on that. So that right there, the difference between those is not going to give me the difference that I'm measuring on those fixture plates that I machined. And honestly, that kind of tolerance right there shouldn't really matter for most of your everyday normal machining operations there, but it will affect it in some ways. It just depends on what your tolerance level is. But this was a fun exercise just to kind of check these guys and see where they're at from where they were manufactured. Now I do know that MMM takes these guys, they machine them, they send them out to be heat treated. I believe they send them out, but they're heat treated, and then they're finished ground after they're heat treated. So these are nice, tough, heavy duty, tough jaws right here. And I think they work really good. This is the only kind that I've used. So the Talon grip jaws, these are, I don't believe these are hardened. I think this is non-hardened steel. So I'm looking forward to seeing how well these guys do. You know, hopefully the same kind of quality work holding that the MMM jaws are going to do. That's just some of the fine tolerance inspecting that you can do on parts once they're finished like that. You would think that a perfectly ground part like that that's done on a surface grinder should be completely flat, but that's not always the case. Sometimes things move on you after you finished your machining processes on it. But this has been fun coming in here to our new granite plate and using it for a little bit of inspection work like this and seeing what our jaws kind of measure out at. So I think I'm going to call this little exercise finished up, and I want to go and probably get a pair of these guys mounted on the Kurt Vise and probably use these because I want to just use them and see how they're going to do, put them to the test on the other two pair of adapter plates that we're going to make, the fixture plates for those V blocks.